Hi friends, welcome to GMATPoint's videos. I'm Sayali Ma'am. In this particular video, we'll be discussing the concept of factors and multiples. Most of you would already know the concept by now. I have discussed it in the previous videos when I mentioned what are factors and even discussed a little bit of multiples. But here we'll take a closer look at it so that we have a firm foundation in these two particular concepts. So let's get started. In this video, I'll discuss what are factors, what are multiples, how to count the number of factors of a given number. I had mentioned it earlier, but now I'll take a very concrete look at this particular concept so that you know for sure exactly how many factors or how to count the number of factors for any given number. We'll also discuss the properties of factors and number and multiples, and in general I have a couple of illustrations based on this particular topic. So let's get started. We'll start with factors. Now, most of you have already seen factors in the previous video. So as I had mentioned, factors are basically numbers that perfectly divide a given number. So if you say the number is 42, the factors of 42 are a set of numbers that perfectly divide 42. That is, perfectly divide basically means that it leaves no remainder. So these are essentially a set of natural numbers that divide 42 without leaving any remainder or leaving a remainder of 0. So which numbers would actually divide 42 without leaving a remainder? 1 would divide 42, 1 divides every number without leaving a remainder. So 1 would divide 42 without leaving a remainder. 42 would divide 42 without leaving a remainder. So 1 into 42, 1 and 42 are factors of 42. So you can write that as 1 into 42, where 1 is a factor, 42 is a factor. Another way to actually find the other factors is just find these pairs of numbers which multiplied together form 42. So what into 2 gives you 42? So 42 divided by 2 is 21. So 2 into 21 is also 42, which means that 2 and 21 are also factors of 42. So in the list of factors, I've gotten 1, I've gotten 42, I've gotten 2, I have gotten 21. The reason why I write it at the very ends is because as you go up, this number goes decreasing. So as this number increases, this number decreases. So this increases, this decreases. And somewhere around the last pair of factors, they become very close to each other or roughly equal to each other. So you know that you have considered the entire list of factors. So if you consider this as a line, so I go down and write 1 and 2 over here, 21 and 42 over here. I know for a fact there won't be any factor between 21 and 42 because there is no factor between 1 and 2 to counterbalance it. So from 21 directly after that there will be 42, which would be the other factor. So these two are the factors, 1 and 2 are the factors. Now let me consider, is 3 a factor? Yes, 3 does divide, perfectly divides 42 without leaving a remainder. So 3 into 14 is a pair which gives us 42 as the product. So 3 is a factor and 14 is a factor. Does 4 divide 42? No. 4 does not divide 42, so it's not a factor. Not 5, not 6 divides 42. 6 into 7. So 6 and 7 are other factors. So if you can see, these are just one apart, so clearly there won't be any factor after this. So you get 8 factors, 1, 2, 3, 6, 7, 14, 21, 42. See, roughly around the point where you can neither increase this nor decrease this any further. You get the midway mark where that is the last pair of factors, and these two factors are the closest to each other. 1 and 42 are the furthest apart from each other, and 6 and 7 are closest to each other as such. And both of these represent, when you take the product, will give you 42. Each of these is a pair of factors. In general, when a number is not a perfect square, you will get perfect pairs of factors. So you will get an even number of factors. So for example, for 42 you have 8 factors. So in general, when a number is not a perfect square, you get an even number of factors. When a number is a perfect square, you get an odd number of factors. Now why is that the case? So consider 16 for example. 16, you have 1 into 16, 2 into 8, 3, 4 into 4. So how many factors do I get? I get 1, 2, 4, 8, 16. So that is a total of 5 factors. The reason why I get odd number of factors is because I can't write 4 2 times, because 4 is just one number in a set. I have to consider it only once. So I get 5 factors. If I get an odd number of factors is odd, that means that the number is a perfect square. For all other factors, all other numbers, the number of factors will be an even number. Okay, so any other number which is not a perfect square, you will have even number of factors. So for example, 48, even number of factors, 49, odd number of factors, because 49 is a perfect square. So this is all about factors and how to actually find factors. We have discussed prime factorization, so I assume that you know how to find the factors and how to factorize a given number. Now let's go to the concept of multiples. So the same way as you have factors, on one side you are actually finding all numbers less than or equal to which can divide a given number. In case of multiples, we look at the other side of the coin. We have to see all the numbers that can be perfectly divided by our given number. So if I have a number n, then n perfectly divides which numbers? N divides n, 2n, 3n, 4n, 5n and so on. Any integral multiple of n would be perfectly divide it. So all of these are essentially multiples of n. As you can see, since there are infinitely many integers, there will be infinitely many multiples. There are limited set for a given number, there are limited number of factors, finite number of factors, but there are infinite number of multiples, because essentially any number of the form k times n would be a multiple of a given number. So for example, if I consider 42 again, so 42 is a multiple of 42, a number is a multiple of itself. Then 84 is a multiple of 42, 126 is a multiple of 42 and so on. All of these are multiples of 42. But remember, a number is a factor of itself, a number is a multiple of itself. So the first multiple of 42 is 42. Okay, so all of these are examples of multiples. Now let us take a look at the concept of number of factors. In the previous example, I told you if the number of factors are even factors, then then the number is not a perfect square. If it has odd number of factors, it is a perfect square. So we'll take a look at the number of factors, how to actually count the number of factors from the lens of prime factorization. So if you remember the concept of prime factorization, that concept is basically you take any number n and you convert it into a product of powers of prime factors. So prime factors, prime numbers are 2, 3, 5, 7, 11, etc. So you convert it into a product of prime numbers, and once you have that product, say basically a raised to p into b raised to q into c raised to r and so on, where a, b, c are prime numbers. Once you have them as a product of prime numbers, according to formula, the formula for the number of factors of n, if you have to find out the number of factors of n, the number of factors of n is given as p plus 1 times q plus 1 times into r plus 1 and so on. So if you have d into z or anything of that sort, you just continue to multiply the product. For example, consider say n is equal to 2 raised to 5 into 3 square into 5 square into 7 raised to 3 and 11 square. If you have a number like this would be a fairly large number. So for this number, would you actually do the prime factorization where you have 1 into 2 something, then 2 into something and 3 into something? There's no way you can actually find out all the factors using that method, nor the tree method, because it would be it would not be easy to consider all the factors of this particular number and count the number of factors of all this number. So this is where this formula comes in. According to the formula, what would be the number of factors of n? According to the formula, the number of factors of n would be, this is 5, so this would be 5 plus 1, that is 6. This is 2, so this is q plus 1 would be 3. This is 2, so this plus 1 would be again 3. This is 3, so 3 plus 1 is 4. This is 2, so 2 plus 1 is 3. So this is basically 6 into 3 into 3 into 4 into 3. So how much is that? This is 18 into 12 into 3. So this is 18 into 36. 18 into 36. Let me try to find an easy way to represent this. 18 into 36. So if I multiply, this is again, so 3 into 2 and 6. So this would be equal to 48, 648. So the number of factors of n would be 648. It has 648 factors. So it is impossible to count it one by one. So this is where the formula comes in. So if you are asked, if this is a large number, what is the number of factors of n? Do prime factorization. Consider each prime factor, find out the index of the prime factor. each index plus 1, take the product of all of those index plus 1 values to get the final value. So if this is 2 raised to 5, you have to take 5 plus 1, that is 6. 6 into 2 plus 1, that is 3. 2 plus 1, that is 3. So 6 into 3 into 3 into 4 into 3, and take all of that product to get the final value, which is 648. So always remember, in these kind of questions, you have to use formula. Now many of you must be wondering, where does this formula come from? See, if I have to consider, say this is my number, okay, n is 2 raised to 5, 3 square, 5 square, 7 cube, etc. And I have to find out which number would be a factor of this particular number n. So one way to actually consider all the factors is basically consider a number, say suppose f is a factor. Now if f perfectly divides n, then what can be consider f is of the form 2 raised to a, 3 raised to b, 5 raised to c, 7 raised to d, and 11 raised to e. Okay, if f is of this form, and it is given that f is a factor of n. So what can be the value of a? The value of a can be 0, 1, 2, 3, 4, 5. Can it be 6? If it is f has 2 raised to 6, then you would have one more power of 2 than in n, and then you would have a fraction. You would have a fraction because the power of f, 2 in f would be greater than the power of 2 in n. So power of the a value cannot be greater than 5. A value can be anywhere from 0 to 5. If it is 0, it becomes that f will be an odd number. So that would be an odd factor of n. So basically a can take values from 0 to 5. Similarly, b can take values from 0 to 2. That means that essentially any number, if a is, say for example 1, 2, 3, 4, I get different factors f corresponding to what would actually be a factor of it. So a can take any value from 0 to 5, and as a changes, I get a different factor of f. Similarly, b can take any value from 0 to 2. If it is 3, then it will not perfectly divide n. Any value greater than 2 will not perfectly divide n. Similarly, c can take any value from 0 to 2. D can take any value from 0 to 3. E can take any value from 0 to 2. So that means that I can select the power of a in 6 ways. 0 to 5 is essentially 6 ways. I can select the power of 3 in 3 ways. I can select the power of 5 in 3 ways. I can select the power of D in 3 ways, and I can select the power of E in this in 4 ways and this in 3 ways. So if I consider all the possible combinations, in how many ways can I have the factors? How many ways can I select a factor? That can be done in 6 into 3 into 3 into 4 into 3, which gives us 648 again, which is our actual answer. So whenever you are trying to understand why is it p plus 1 into q plus 1 into r plus 1, think of it as the number of ways you can select the power of a prime factor. You can select it from 0 to p ways. So 0 to p means total of p plus 1 ways. So that is why you have to multiply p plus 1 into q plus 1 into r plus 1. Now this begs the question that if this is the case, okay, how many even factors will be there? See, if you have to consider even factors, then f has to have at least one power of 2. So a cannot be 0. If I have to consider that f is an even number, if f is an even number, a at least has to be 1. If a is 1, then f will be an even number. If a is 0, f will be an odd number. So a can go from 1 to 5. So this will not be 6 ways, this will be 5 ways. So if I have to consider number of factors, if I say number of even factors, what do I get? If p is the power of 2, then the number of even factors is p into q plus 1 into r plus 1 and so on. This is the number of even factors. If I have to consider the number of odd factors, what would it be? Then the value of a can only be 0, and only then will I get a odd factor. So in this case, the value of a is 0, and then I get the number of odd factors. This can be done only in one way. So I select the power of 2 in only one way, which is 0, and then all of the others remain the same. So in this case, what do I get? I get that number of factors is p plus 1 into q plus 1 into r plus 1 and so on, when p is the power of 2. So in this case, if p is the power of the prime number 2, then this number of factors can be selected in p plus 1 into q plus 1 into r plus 1 ways. The number of even factors would be p into q plus 1 into r plus 1 and so on, and number of odd factors correspondingly would be 1 into q plus 1 into r plus 1 and so on. If you add both of them together, you take all of this in common, it becomes p plus 1, which is the number of total factors. So number of factors, total number of factors for any number, when you have prime factorized it in that way, is p plus 1 into q plus 1 into r plus 1 and so on. Number of even factors, where p is the power of 2 in that number, is p into q plus 1 into r plus 1 and so on. Number of odd factors would be q plus 1 into r plus 1 into and so on. So that is the basic thing that you have to understand when you have to consider the number of factors as such. So these are the formulas that you should remember for the number of factors. The most important formula is this one. If you understand the concept of prime factorization and considering or counting the number of factors, then you can infer these two formulae, but these two formulae are far less important than this main formula, which is that of number of factors as such. So now that we know the concept of number of factors, let's take a look at the concept of properties of factors. So as you can say, one of the important things that you have to remember of factor is that for every number, 1 will always be a factor, and the number n itself, for a given number n itself will also be a factor as such. So 1 and n, for any given number n, there will be at least 2 factors. So if there are only 2 factors, then the given number is a prime number. If there are more than 2 factors, then we have a composite number. Okay. Every factor, if you have to consider, if I am looking for the list of factors, okay, if I am looking for the list of factors, every factor f of a number n will have to be less than or equal to n. So beyond n, I need not look for factors. So if I am looking for 42, I have to consider all the numbers up to 42. I need not consider is 43 a factor of 42, because that number is greater than 42. It will not perfectly divide 42. It will always be a fraction as such. So that means that every factor will be less than or equal to n. Okay. Now let's take a look at the properties of multiples. Always remember, every number is a multiple of itself. So you always begin, if you consider the list of multiples, you have to begin with the number itself. Then you have 2n, 3n and so on. Another thing that you would notice is if you consider the list of all numbers, kn and all, you see that if you take the difference of any two multiples, that difference will also be a multiple of n. So suppose I take 10n minus 2n, I still get 8n. So that means any difference of any two multiples of the given number n will also be a multiple of n. Similarly, if I consider sum of any two multiples of n, that will also be a multiple of n. So this will be also 12n. So if I take difference, so an minus bn, I can take this as a and b are both integers. So this will become a minus b times n. So this is also a multiple of n. Similarly, for sums I have an plus bn, and this is equal to a plus b times n, which is also a multiple of n as such. So whether you take the sum or a difference, this will always be the sum and difference of multiples of a given number will also be multiples of the given number. Also remember that if n is a integer, then any multiple of n will also be an integer. So if you start with 42 and you have k times 42, where k is an integer, this will also be an integer always. All multiples of an integer will be an integer. So these are the basic properties of factors and multiples. Now that we understand all of those properties and the formula associated with them, let's take a look at a few questions based on this topic. So consider this question. The number of factors of a number is equal to 72. If a and b are the only prime factors of the number, which of the following cannot be the representation of the number? So a and b are the prime factors. Let's consider the first case. So a raised to 17 into b raised to 3. So in this case, what would be the number of factors? The number of factors would be 17 plus 1, so that is 18, into 3 plus 1, that is 4. 18 into 4 is 72. So the number of factors will be equal to 72. So a would not be incorrect as such. Consider option B. So a raised to 11 into b raised to 5. So 11 plus 1 is 12 and 5 plus 1 is 6. This product is equal to 72. So again the number of factors will be equal to 72. Consider this, a raised to 35 into b raised to 1. So in this case it would be 36 into 2, so that is 72. So again the number of factors will be equal to 72. This is an incorrect option. This this would be a fair representation of the number. A raised to 7 and B raised to 8. So 7 plus 1 is 8. 8 plus 1 is 9. 8 into 9 is 72. So this also fits the given criteria. So the last one would be 14 into 4. 14 plus 1 is 15 into 4 plus 1, that is 5. So this is equal to 75. So the number of factors for option E would be 75, which is not 72. So this cannot be the representation of the given number. So E is the right option to choose. So if you know the formula, this would be a trivially easy question to answer. Just take one more than the index, take the product of all of those numbers, and you have your required answer. Now let's take a look at the next question. So we have 58A is a 3-digit number. So we have to find what A is. So 58A is a representation of a 3-digit number where 5 is in the hundreds place, 8 is in the tens place, and A is in the units place. So we have to find out the A units place digit. So first statement is 58A is a multiple of 7. So how many numbers in 580s are multiples of 7? So let us consider 580, 560 would be a multiple of 7, 588 would be a multiple of 7, 581 will also be a multiple of 7. So 581 is perfectly divisible by 7, that is 80, this is 80, so this is a multiple of 7, this is 83 into 7. And 588 is also a multiple of 7, that would be basically 84 into 7. So both of these are multiples of 7. So if you have just statement 1, you get two possible values for A. You can have either A is equal to 1 or A is equal to 8. Since there are two multiples of 7 in the range of 580s, we can't uniquely find the value of A. So statement 1 alone is not enough to actually answer the given question. Now consider statement 2 alone. So 58A is a multiple of 12. If it is a multiple of 12, what can you actually say? Which of these would be a multiple of 12? If you consider 600 is a multiple of 12, minus 12, 588 is a multiple of 12. So multiple of 12, 600 is a multiple of 12, 588 is a multiple of 12, minus 12 would be 576 is a multiple of 12. So in the range of 580s, only 588 is the only multiple of 12. So if the 588 is a multiple of 12, then A has to be equal to 8. Since there are only one multiple of 12 in the given range, then I can say that just using statement 2 alone, I can uniquely determine the value of A. So statement 1 alone is not enough, but statement 2 alone is enough to actually answer the given question. So the right option to choose would be B. Statement 1 alone is not enough, but statement 2 alone is enough to actually answer the given question. So as you can see, this is the important concepts that you should know about factors and multiples. Now that you understand these concepts, please take the accompanying concept test, and thank you for tuning in.